Objective of this lesson is to learn about nested loops in Python. So what are nested loops? A nested loop is when a loop is inside another loop. Any type of loop can be nested inside any other type. This means that you can have a for loop which is inside another for loop, or you can have a for loop which is inside a while loop, or you can have a while loop which can be nested inside another while loop, and you may have a while loop which can be nested inside a for loop. Here is a syntax of a nested loop. In this example, a for loop is nested inside another for loop. As you know, the outer for loop starts with the keyword for, with an iterating variable and a keyword in, and a sequence and a colon. In the body of the outer loop, you can have some statements, and then you can start an inner loop, which again starts with the keyword for, and of course it has a different iterating variable. And just notice that the body of the inner loop is also tabbed one more time. So all the statements that you want to put in the body of the inner loop have to be tabbed twice. And after that, you can have some statements which are in the body of the outer for loop. What you see in blue here belong to the inside for loop, and what you see in yellow belong to the outer for loop. Here is another example using the while loops. The basic syntax is basically the same. You have an outer while loop, some statements after the outer while loop. You can put another while inside the while. And remember again that the statements who are inside the inner while loop have to be tabbed twice. And then, of course, the rest of the body of the outer loop can continue. Here's an example of using nested loops. Let's consider a problem. Find and print all the prime numbers between 2 and 50 using only while loops. And the second example is the problem when you want to find and print all the prime numbers between 2 and 50 using only for loops. Before I write these two examples for you, I would like to give you the algorithm for finding if a number is prime. First, you select a number, then you select the divisor and set it equal to 2. Then assume the number that you selected is prime. Then, if the divisor is less than the number, you go to step 5. Otherwise, you go to step 8. Then you divide your selected number by the divisor, and if the remainder is 0, that means that your number is not prime. In that case, you are done. You basically exit or stop the program. Otherwise, you add 1 to the divisor and go to step 4. There is a loop which goes between step 4 and 7. Here is a program which is the implementation of the algorithm to determine if a number is prime. In this line, I have selected a number. In this case, let's say my number is 23, and I want to determine if that number is prime. In the next line, I am setting the current divisor equal to 2. In the next line, I will use a variable called isCurrentNumberPrime, and I set it to true. That basically means I'm assuming that my number is prime. Then I will have a while loop, and this while loop continues as long as the current divisor is less than the current number. Then I use the modulo operator to determine if the remainder of the current number divided by current divisor is equal to 0. If this happens, that means my current number is not a prime number. So in that case, I will set the variable isCurrentNumberPrime to false, and then I will break out of this while loop, which basically means I will jump to this statement. Otherwise, I will add 1 to my current divisor in this line and then go back to the while loop. If the while loop continues and finishes without getting to this break statement, I will come to this statement and then I will print current number is prime, and then I say all done. So let's run this program to see what happens. So as you can see, it says 23 is prime and then goes to the print statement and says all done. Now, as an exercise, let's say if I select my current number to be 24 and run it, you can see that it only says all done and it doesn't say that 24 is prime. I could have printed the fact that 24 is not a prime. All I had to do, I can say simply else, then I will print current number, and then if I run my program this time, you see that says 24 is not prime. Now that I have this base program here, I can put this entire program inside another loop, which basically selects my current number to go from 2 to 50, and each time calls this program. First, I'm going to change the comment on the top of a program to reflect what I am doing. And I say a program to print all the prime numbers between 2 and 50. To make my program a little more general, I don't like to use constant. So what I will do, I will say my start number is 2, my end number is equal to 50, and I set my current number equal to start number. I do not need to set my current number explicitly. I will start another while loop which says while my current number is less than or equal to my end number, this while loop is going to continue. Since I have to put this portion of the program inside the outer while loop, I have to tab all of them. This while loop now becomes an inner while loop, so it has to be tabbed. If the number is not prime, let me not print it, just ignore it. And what I have to do when I get to the end of this while loop, I have to add 1 to my current number. So I will test my next number. This time, if I run my program, you see that it will print all the prime numbers between 2 and 50. This is an example of this while loop being nested inside this while loop. Notice that this print statement is out of both of them, and also notice that when you use this break statement, it breaks out of the inner while loop because it is inside the inner while loop. Since my program is generic enough, I can change these two numbers. Let's say if I want to see all the prime numbers between 100 and 200, then I run my program again, and here are all the prime numbers between 100 and 200, or all the prime numbers between 2 and 2000, and here are all the prime numbers between 2 and 2000. Next, I am going to convert this program such that it uses nested for loops. Notice that the task of this while loop is to change my current number going from my start number to my end number. So I can simply change it to a for loop by using a range function to go from my start number to my end number. However, notice that since I want my end number to be included, then I have to go from my start number to end number plus 1. And this will take care of converting this while loop to a for loop. Of course, since it is a for loop, it automatically goes through each one, so I don't need this statement here. Let me change this to 50. Now if I run my program again, you see that it prints all the prime numbers between 2 and 50, and this is a case when I have a while loop inside another for loop. Next, I'm going to change the inner while loop to a for loop. So I want my current divisor to go in the range of 2 to my current number. Now remember that this time I don't have to put +1 here because I do not want my current divisor to be equal to the current number. So this range causes it to go from 2 to current number -1. Now since the current divisor is automatically set by this for loop, I do not need this current divisor here. And also, since the for loop takes care of incrementing the current divisor, I do not need this other incrementing statement. This time, if I run my program again, you see that again it prints all the prime numbers between 2 and 50. I should mention that this is just a sample program and it is not an efficient way to calculate prime numbers, and there are more efficient algorithms to do so. What did you learn in this lesson? You learned about nested loops.